So next, I will go over the question for games. So we have an expected max and expected minimax, and the leaf node values are between 0 and 10. And the node will choose the left branch with chance 0.8. So, okay, so we'll fill out the values for them. Firstly, it's a minimizer. It's 3. It will be 3, 9, 0, 5. So m will be 0.8 times 3 plus 0.2 times 9, which will be 40.2. N will be 1, and it is a maximizer, so it will choose 4.2. The root will be 4.2. Given the expected max problem, which node can be pruned in alpha beta pruning? So for this question, we'll look from left to right, and this is just for the 4 leaf nodes of the left expectimizer. We cannot prune anything because we need to determine the value for m. Then we go to 5 and then 0. What we see from here is after we select 0 here, then this value will be like 0.8 times 0 plus x times 0.2. And the range for x is from 0 to 10. So if we give x the maximum value 10, even if x is 10, 10 times 0.2 will be 2, which will be less than 4.2. And so we will prune G and H. We don't need to look at G and H because the maximizer will definitely choose the left branch. Okay. And it says, do not prune on equality. This is very important for this question. So what is the maximum number of nodes that can be pruned? So all these 4 nodes should be chosen because we need to determine the value for this one. And for here, if we have like this value is 0, right? If this value is 0, then this minimizer will choose 0 here. And for like, we want to maximize maximum number of nodes to be pruned. So why not give all of them the value 10? So we have the maximum value like 10. So this node will be 0.8 times 10 plus 0.2 times 10. It will be 10. If it's 0, then no matter how big the value for this, and this to be, this right node will be guaranteed to be less than 10 because 0.8 times 0 plus 10 times 0.2 is still 2. So we cannot, so we don't need to look at them because the maximizer will definitely choose the left branch. So that's why the maximum nodes that can be pruned are 3. Okay, so for this question, we're not given P, and the question wants us to determine what a value should be for P. So we just fill out all the minimizers. So it's 3, 9, 0, and 5. And it says for what value do we have the maximum number of leaf nodes that can be pruned? So for M, yeah, for this question, we don't know the P. So we will model it like we'll just call it P. So it's 3 times P plus 9 times 1 minus P. This value should be strictly large than the right. Will be large than or equal to. So the left branch is, so it's like we want to prove 3 leaf node. So we can only look at 1. So 1 times P plus 1 minus P times something. So what should we fill in here? Like we can, like how we think about it is, so suppose like we already know 1 will be at least, like the other value should be at least smaller than 1. Will the minimizer choose that one? But here, so we use 1 times P. And for the second one, we want to make it the maximum value, which is 10. So if in this case, the left branch is still large than the right branch, then it is guaranteed that this algorithm will stop when it's CE. So if we solve this inequality, we get P is large, then, oh no, so we shouldn't, so we don't prune on equality, so that's why this should be large then. And so just solving this inequality, we get 9 minus 6P is large than minus 9P plus 10, and 3P larger than 1, P larger than 1/3. This is 1/3, and P is a probability, so it should be less than 1. And this will be our result. So the next one, we consider a new problem, which like we have defined a new node called the median, the medianer. And for this one, like this problem has a, like for the medianer, we haven't learned it during the lecture. However, it appears on one of the discussions worksheet. So it's discussion 2P exam prep. And if you want to refresh this concept, you can also look at there. So it says for X is 1 and Y is 2, what is the value for root node? It's just a question to get us started. So if this is 1 and Y is 2, it will choose the median value, 5, 6, 5, 6. And the maximizer will choose 6, and the value for the root node will be 6. And then for the remaining part, we just assume X and Y are any integer between 0 and 10 inclusive. And we also don't prune on equality. So all the possible values that the root node could be. How to find that? So what changes is for these two medianers, their value we don't know. And for these two, we know their value. So X can be 0 to 10. What's the range? So the medianer actually gives you the range for the value of this medianer. So it will be from X, it's larger than or equal to 0, less than or equal to 5, then A's value will be 5. And if X is larger than 5 and less than or equal to 10, then A's value will be 10, or will be X. So X's value could be, so here, this value could be in a range from 5 to 10. And for here, Y's value, we can see if Y is, for B's value, if Y larger than or equal to 0 and less than or equal to 6, then Y's value, B's value could be 6. And if Y is larger than 6 and less than or equal to 10, then then B's value will be 7. So B can be 6 and 7. So, and this maximizer will choose the maximum value amount of 4. So that's why it's the root node could be 6, 7, 8, 9, and 10. Right. So question 3, select all the leaf nodes that are guaranteed to be pruned for any value of X, Y. Yeah, it's pruning again. So we clear all the previous results. Yeah. So here, what we know is, for this one, we just don't know. We don't know. We only know its range is from 5 to 10. And for second one, its value is 6. If it get 6, then the following node or following medianers could not be value less than 6. Since we say we don't prune inequality, they can be 6. And we'll look at it. So for this one, for this node, we can see the first one is 5, the second one's 0. Then what it says is the maximum value for here will be 5. Why it's 5 is like, if suppose I is from 0 to 5, then the medianer, this value will be I, the value for I, but I is from 0 to 5. And if I is from 6 to 10, then I will be the maximum. This value will not, this node will not choose I, and then it will also be 5. So the maximum value for this node is 5. That's why we can prune I here. And here we know 6, Y we don't know, and we cannot say anything about it. And we don't prune anything here. So what we prune here is I. The last question, it says, we want to determine all possible values for X and Y such that the maximum number of leaf nodes can be pruned. So we want the maximum value to be pruned, which just says we want X. So you want to clear the result here. Yeah, so we want the maximum value nodes to be pruned. For these 3, we cannot prune them because we need to determine the value for this medianer. For 0, 6, 8, for the first 2 values, 0 and 6, they actually gives a bound to this medianer, which says this thing will be at least as at most as big, at most 6. Because if f is large, like 7, 8, 9, 10, then e will be 6. If f is smaller, then that value will be that value. So we can see that we can find a method to prune f. If f is like, if x is value large than 6, like 7, 8, 9, 10, then this will be large than the maximum value of the middle one. This one's value will be larger than the maximum value of the middle one. So f will be pruned. So it seems 7, 8, 9, 10 will be promising. And we follow that. We can see G is 5 and H is 0. And this also gives a bound to this mediator, which says the maximum value for this will be 5. And so 5 is also smaller than 7 and 9, 10. So yeah, we can also prune I in this case. And then we go to Y. So if J is 6, K is Y, then like J, we cannot prune it, but for Y can be anything, but we want to prune L if it's possible. So if Y is very large, like 7 or 8 or 9, then it says the maximum value for this can be 7, 8, 9, 10. And we cannot determine it. So if we want to prune this L, what we want to do is make Y as small as possible. So Y can be 1, 2, 3, 4, 5, 6, and can Y be 7? No, right? Since this one gives us X, if X is 7, then this node is 7. And if Y is 7 and the next node is also 7, then this median value will also be 7. Since we don't prune inequality, we cannot prune this. And so in order for the maximum value nodes to be pruned, like this one to be pruned, we should make sure Y is smaller than 7. So Y cannot take 7. So X's value will be 7, 8, 9, 10, and Y's value will be 1, 2, 3, 4, 5, 6.